Did you know that the sun's poles are about to reverse? And more importantly, should you be worried? This isn't a plot for a science fiction movie, but a real celestial event. It might sound strange, even alarming, but the sun's poles do indeed reverse, and quite regularly at that. First, let's get the basics. Just like our Earth, the sun also has a north and south pole. However, unlike Earth, the sun's poles flip approximately every 11 years. This event is part of the sun's solar cycle, a cycle that governs various solar activities and phenomena. This polar switch is an integral part of this solar cycle and is known as the solar maximum. Now, you might be wondering, why does this happen? It all comes down to the sun's magnetic field. The sun is a giant ball of electrically charged gas, and this movement generates a powerful magnetic field. Over time, this magnetic field gets tangled and twisted, and eventually, it needs to reset itself. This resetting is what causes the sun's poles to switch. In this video, we will dive into the fascinating world of our sun and its magnetic field. We'll explore the process of the sun's poles reversing, the effects of this reversal, and whether or not this is something we should be worried about. We'll talk about how the sun's magnetic field affects space weather, the stunning visuals of auroras, and the potential risks to our technology. We'll also touch upon the science behind these phenomena and the research that helps us predict and understand these events. So, let's delve deeper to understand this fascinating phenomenon. Are you ready? To fully grasp the sun's poles reversing, we must first understand the sun's magnetic field. Picture the sun as an enormous dynamo, a giant generator that produces a vast magnetic field. This magnetic field is created by the movement of plasma, a state of matter that makes up over 99% of the visible universe. In the sun's case, this plasma is superheated, charged gas, constantly swirling and churning. The sun's core is a raging nuclear furnace where temperatures reach millions of degrees. Here, hydrogen atoms are smashed together to create helium, releasing energy in the process. This energy pushes outwards, creating convection currents that carry heat from the core to the sun's surface. These convection currents of plasma generate electric currents, and where there are electric currents, there's a magnetic field. So, the sun's magnetic field is not fixed like Earth's. Instead, it's a complex, ever-changing structure. Imagine a pot of boiling water on the stove. As the water boils, it creates bubbles that rise to the surface and pop, creating a chaotic, ever-changing pattern. Similarly, the sun's magnetic field lines are constantly bubbling up to the surface, creating areas of intense magnetic activity. These areas of intense magnetic activity are what we see as sunspots, dark patches on the sun's surface. They're cooler than the surrounding areas, which is why they appear dark. But don't be fooled by the term cooler. They're still hotter than anything we can imagine, with temperatures around 4,000 degrees Celsius. These sunspots are the source of solar storms, violent eruptions of energy that can send charged particles hurtling towards Earth. When these particles collide with Earth's magnetic field, they can cause stunning displays like the aurora borealis and the aurora australis. Now that we understand the sun's magnetic field, let's explore what happens when the poles reverse. The sun's poles reversing is not an overnight event. It's a gradual process that takes place over several years. Picture the sun as a giant magnet, with a north pole and a south pole. Now imagine that these poles are gradually switching places. Sounds like science fiction, right? But it's actually a regular occurrence in our solar system. This reversal is part of an approximately 11-year cycle known as the solar cycle. During this cycle, the sun's magnetic field twists and distorts. The sunspots, which are regions of intense magnetic activity, increase in number and move from the solar equator towards the poles. As they move, they carry magnetic field lines with them. This migration of sunspots is one of the key signs scientists look for to know the reversal is happening. The more sunspots there are, the closer we are to a solar maximum, the peak of the solar cycle when the sun's magnetic field is the most distorted. As the sunspots reach the poles, they cancel out the existing magnetic field, effectively clearing the stage for the poles to switch places. The sun's magnetic field then resets, and the process begins anew. But how do scientists track this? Well, they have a few tools at their disposal. Instruments on solar observatories and spacecraft measure the sun's magnetic field and monitor sunspot activity. Plus, the appearance of auroras, like the aurora borealis and aurora australis, can signal that the sun's magnetic activity is on the rise. The entire cycle, from one solar minimum to the next, takes about 11 years. But the reversal itself? That can happen in as little as a few months. It's a spectacular cosmic ballet that's been taking place for billions of years. So, now that we've understood how the sun's poles reverse, let's move on to the effects of this reversal. With the process clear, let's now discuss the effects of this reversal on our daily lives. You might be wondering, what impact does the sun's poles reversing have on us here on Earth? Well, the answer is fascinating and not as alarming as you might think. To start with, the most significant effect of the sun's poles reversing is changes in solar radiation. During the reversal, the sun's magnetic field weakens, reducing the shield it provides against cosmic radiation from deep space. This leads to an increase in the amount of cosmic radiation that reaches the Earth, which can cause changes in our planet's atmosphere and climate. However, these changes are usually minor and part of a natural cycle that our planet has experienced for billions of years. Another effect of the sun's poles reversing is the impact on technology. Our modern world is highly dependent on technology, and many of these technologies, such as satellites, GPS, and communication systems, can be affected by increased solar and cosmic radiation during the sun's pole reversal. For example, solar storms, which become more frequent during the reversal, can disrupt satellite communications and power grids, leading to temporary outages. But don't worry, scientists and engineers are well aware of these effects and have designed systems to withstand them. Now, on to something spectacular: the auroras. You might know them as the northern and southern lights, those beautiful swirling colors in the night sky. These are caused by solar particles interacting with the Earth's magnetic field, and during the sun's pole reversal, these auroras can become more frequent and can be seen at lower latitudes than usual. So, if you live in a place where you don't usually see auroras, the sun's pole reversal might be your chance to witness this natural light show. But what about the catastrophic effects you might have heard about? Could the sun's poles reversing cause massive solar flares that wipe out all technology? Or even worse, could it cause the Earth's poles to reverse, leading to catastrophic climate change? The answer to both of these questions is a firm no. The sun's poles reversing is a natural process that has happened countless times in the past, and it does not have the power to cause such catastrophic effects. Even the increased solar and cosmic radiation during the reversal is not a significant threat to human health. Our planet's atmosphere and magnetic field do a great job of protecting us from these radiations. And while astronauts in space are at a higher risk, measures are taken to protect them during periods of increased solar activity. So, despite the changes that the sun's poles reversing can bring, there's no need to panic. The effects are manageable, and life on Earth has adapted to this natural cycle over billions of years. In fact, the pole reversal is a testament to the dynamic and ever-changing nature of our sun, reminding us of the intricate and fascinating processes that keep our solar system ticking. Despite the changes, there's no need to panic. Let's find out why. So, the sun's poles are reversing. Should we be worried? A question that might have been running through your mind since we started exploring this fascinating topic. Let's dive right in and address this. The short answer is, no, we shouldn't be worried. This is a natural, regular event in the life of our sun. It's not an anomaly or a sign of impending disaster. It's just the sun doing its thing, something it has been doing for billions of years. So why aren't we in a panic? Well, scientists have been monitoring the sun's activity for quite some time. They understand the cycles, the patterns, and the behavior of our nearest star remarkably well. These cycles of pole reversal, referred to as solar cycles, occur approximately every 11 years. We've observed this happening for centuries, and we're still here, still thriving. But let's not be completely dismissive of the event. The sun's pole reversal does have effects that reach all the way to Earth. Solar storms, for instance, can disrupt our technology, affecting satellites, power grids, and even airline passengers. However, we have measures in place to protect our infrastructure. Satellites are built with protective shields, power grids have safety protocols, and airlines can alter flight paths to avoid high radiation levels during solar storms. It's also worth noting that these pole reversals bring about some of Earth's most beautiful natural phenomena, like the aurora borealis and aurora australis. These dazzling light shows are the direct result of solar storms interacting with our planet's magnetic field. In essence, while the sun's poles reversing is indeed a significant event, it's not something that should cause alarm. It's a testament to the dynamic, ever-changing nature of the universe we inhabit. It's a reminder that we are part of a cosmic dance that's been going on for eons. So, as intriguing as the sun's poles reversing is, it's not something that should keep you up at night. We've covered a lot of ground today, haven't we? We've journeyed from the surface of the sun, delved into its complex magnetic field, and explored the fascinating process of solar pole reversal. Let's take a moment to recap what we've learned. First, we embarked on understanding the sun's magnetic field. It's not static, as you might think. Instead, it's a dynamic, ever-changing force. Our sun, like a gigantic magnet, has two poles. But unlike the magnets we're familiar with on Earth, the sun's magnetic field is in a constant state of flux, leading to the phenomenon of the sun's poles reversing. Then, we dove into the process of the sun's poles reversing. This isn't an overnight event. It's a gradual shifting that occurs over an 11-year solar cycle. As the sun's magnetic field lines get twisted and tangled due to the sun's differential rotation, the poles eventually flip. The sun's magnetic field weakens, becomes more complex, and then finally reorganizes itself with the poles reversed. This is a natural part of the sun's life cycle. We also explored the effects of the sun's poles reversal. It's a spectacle that can lead to increased solar activity. The sunspots, solar flares, and coronal mass ejections become more frequent. This increased activity can lead to more spectacular displays of auroras on Earth, but it can also pose risks to our technology, such as satellites and power grids. However, with advanced prediction and preparedness, these risks can be managed effectively. Finally, we address the million-dollar question: should we be worried about the sun's poles reversing? The answer, in short, is no. While the sun's poles reversing is a dramatic event, it's a natural part of the sun's life cycle and has been occurring for billions of years. It does lead to increased solar activity, but it's not a cause for alarm. This is a testament to the marvels of our universe and the dynamic nature of our sun. It's a phenomenon to be studied, understood, and appreciated, but not feared. So the next time someone mentions the sun's poles reversing, you'll know exactly what they're talking about and you can reassure them. There's no need to worry.